Hi, this is Mrs. Lee from Todd Beamer High School, and today we are doing Appendix B Activity 2. And if you were not here for, or if you did not watch Activity 1, you will probably want to go do that because a lot of the stuff that we're doing here for Activity 2 assumes that you know all the properties of exponents. If you don't know them, go back and do that. And okay, so I'm assuming that you do know it now. Please take the time, just pause this video, do as many as you can, you know what I mean? And then unpause the video and let's check your work. All right, so I'm assuming you've done as much as you can, maybe all of it, right? And here, remember 13 to the 0 power, that's just 1. Anything to the 0 power is 1. And if you don't know why, again, watch Activity 1 video again. And 5 to the 3rd power, remember that's 5 times 5 times 5, which is just 125. And then 5 to the negative 3rd power. Remember that negative 3 does not mean that it's a negative number, right? It just means, remember, if you remember back, the negative exponent just means that it's 1 over. So it's 1 over 5 cubed. Okay, that, I need to write that a little bit better. That looks like 1 over 53, which it's not. So 1 over 5 cubed. There we go. And we know that 5 cubed is just 125. So that's going to be 1 over 125, just like that. Okay, so that's what the negative number does, the negative exponent, right? It just, since the 5 is on, the base is on the top of that fraction, it's going to go in the denominator. Let's take a look here. And right here, 3 to the 4th times 3 to the 7th. Remember, same basis. What are we going to do those exponents? That means we have 4 3s over here and 7 3s over here, which means altogether, how many 3s do we have? 11, right? And so that's going to be equal to 3 to the 11th. And we're going to just write it like that. We're going to leave it as 3 to 11th because that's actually a really big number. All right, and then moving on right here, if you have 2 to the 7th, divided by 2 to the 3rd. So we have 7 2's on top, 3 on the bottom. So how many cancel out? 4, 3 of them. So 4 of us left, 4 on top. So that's going to be 2 to the 4th power. If you, I usually do it like that. I try to logically reason it out, right? But if you remember the rules for that, I remember you just, since you're dividing the bases, you are actually subtracting those exponents. But for me, I just think I don't like to remember rules. I just like to logically reason it out, go, okay, this makes sense. All right, so there we go. So that would be 2 to the 4th. And here again, so this is 3 times y squared 3 times. So we have 3 groups of them. So that's going to be 3 to the 3rd power. And then this is going to be, so power to a power. So it's y squared to the 3rd power. So we have y squared times y squared times y squared, right, which is y to the 6th power. Or shortcut way, remember, is just going 2 times 3 exponents, right? So that would be 6. And then I'm just going to simplify the 3 to the 3rd power. And that's going to be 3 times 3, which is 9, times 3, which is 27. So it's 27 y to the 6. And some of you guys may be wondering, like, how come, Miss Lee, sometimes you like leave it as an exponent, like with the exponent there, and sometimes you just do it, right? Like 5 to the 3rd power, like, you know, when do you just do that, right? So if it's like something like this, like number 10, where it's like some really big number, usually like we'll just let you just leave it at 3 to the 11th, right? And we're practicing these power exponents and all that kind of stuff, the properties, right? If it's something like 2 to the 4th, can you have done like the number? Yes, but it's also as a teacher, we're looking for, okay, do you know the, what is it called? Do you know the properties, right? And so this would indicate, yes, you know the properties, right? So that's all. 3 to the 3rd power, yeah, 27. It's a pretty small number, so we're just gonna leave it at that. And then a to the 0 power, remember the 0 is not, does not affect the 4, right? It does not affect the 4 because there's no parentheses, right? So the 0, the exponent is just for the a, not for the 4. So this is just gonna be 4. And then what is a to the 0 power? Just 1. So 4 times 1, which is just 4. And then k to the negative 1, Remember, it's just like 5 to the negative 3, right? So it's just going to be 1 over k to the 1 power. And we know that k to the 1 power is just k. So if you went straight to 1 over k, that's totally fine. You don't have to do that middle step. I just did that just to be very, very clear. All right, and moving on here, this is y squared. Now, if you wrote down just 9 on the bottom, you'd be like, that's not correct, right? Because remember, this has parentheses, so this square is for both the w and the 9, for both of them, okay? So make sure you put that square right there as well. And so it's going to be w squared over 81, just like that. And then here, not much to do. See, we have a d squared and a d to the 3rd power, right? Which means that's how many d's that we're multiplying? That's going to be 2 times d to the 5th power. And that's all we can do. And remember, this 2 does not have any exponents. So this the squared does not apply to the 2 because, again, there are no parentheses. Okay. And then, number 9. A to the 0 times b to the 0 times c to the 0. That's just 1 times 1 times 1, which is just 1. Happy days. And then our last one right here. So this is going to be, remember, it's power to a power. So if you remember way back in the day, like activity 1, not that way back in the day. So the long way to do this is just go km squared times km squared times km squared. Because remember, that this cubed means that you're doing this 3 times, or you're multiplying whatever's inside the parentheses 3 times. And so how many k's do we have? Oh, we have 3 of them. K cubed. And then we have how many m's? We have 2 m's here, 2 m's here, and 2 m's here, which means that that's going to be m to the 6th power. All right. And again, if you remember the power to a power rule, right, the property, so that's just going to be k. Remember, if there's no exponent, that just means it's an exponent of 1. So it's 1 times 3, which is 3, and 2 times 3, which is 6. Okay, I don't like to memorize rules unless I know what it means and why it's a rule, right? So that's and that's how I always reason it out. Because really all throughout high school, I never really memorized stuff. I just tried to logically reason it out because it needed to make sense to me. I don't know. I was just like that. It needed to make sense. And then for number 13, again, if you have not done this yet, try to do it yourself. The best way to learn is just try it out and see, logically reason it out and see if you got it. And sometimes you'll be like, oh yeah, I forgot about that part, right? So this would be a good way. So pause now. Assuming you paused and you've done number 13. And so here it is. So we're gonna say whether it's sometimes true, always true, or never true, okay? And so if a is a positive integer, so an integer like 1, 2, 3, 4, 5, it would not be like 0.5 because 0.5 is not an integer, right? Integer is like a whole number, so it's basically a whole number in this case, because we could have negative integers, but it's asking for positive integers. So those are the ones. So here we go. So then x to the negative a is equal to 1 over x to the a. Okay, so if that is a positive integer, which means, so if I always write a number like 5. So if a is 5, then this would be, oh, let me write it over here. X to the negative 5, right? Because it's the negative of a, and my a is 5. So you know what I mean? So that'd be negative 5 is equal to, and yes, that would be 1 over x to the 5th power. And that's always true, because as long as this is a positive integer, yes, this is always true. Because if this was, let's say, if it just said integer, then there could be a negative 5 and a negative of a negative, right? That would make it a positive, in which case it wouldn't be a 1 over kind of thing. But yes, there we go. It is always true. If x is positive, then x to the negative n power is negative. Okay, so x is positive. So let's make that positive 2. I'm just picking numbers. You know, I just like to try numbers and see, does it work for this number, right? Because if it works for this number, then, and if I'm like still a little bit skeptical, I'll try another number, right? But just make sure it's following the rules. So if I wouldn't pick -2 because -2 is not positive, right? That doesn't work out like that. So it says 2 to the negative n, right, is negative. So this means that I'm multiplying two an indefinite, well, let me just do this. So it's equal to 1 over 2 to the n. Now, if you notice here, that is still a positive number. And this exponent just means that's how many times I'm going to multiply the 2 by, right? At any point, am I multiplying by a negative number? No, it's just going to be 1/2 times 1/2 times 1/2 times 1/2, right? So, or technically it would be 1 over 2 times 2 times 2 times 2 is on the bottom, right? And that's never going to be negative. So yeah, because 2 is not a negative number. All right, and so if n is 0, okay, then x to the negative n, okay, so we're saying that x to the negative 0 is 1. Well, what's negative of 0? 0. So this is actually equal to x to the 0 power. We know that anything to the 0 power is 1. So yep, that's true. It's always true. That's no two ways about that. So far nobody has anything for sometimes. If n is a negative number, okay, so n is a negative number. So we chose 2 here. Let's choose negative 2. All right, let's see what happens there. Then, so here goes. Negative 2. Oh, just kidding. That's n, not x. Sometimes we got to read the fine print there, right? So here goes. X is equal to, x is right here. And then to the negative of negative 2, right? Because it's the negative on the outside of n, and then n is negative 2. So far, so you got that? All right, so that's going to be equal to, so the negative of negative 2 is going to be x to the positive 2. So it's just x squared. It's like if you not do something, if you not washed your face, did you wash your face? Yes. I'm gonna not listen to you. But that means you're gonna listen to me. Exactly. So that's how it's gonna work. So this is x squared. So is x squared 1? Well, I mean, if x was 1, then yes, that's true. But what if x was 5? Then that'd be 5 squared, and that would be 25. So that would be not true. So it's sometimes true, sometimes not true. So therefore, we're going to be like, okay, sometimes, oh, we're just talking about this sometimes, right? All right, so now if x is 0, okay, x is 0, got it, x is 0, so we got 0. And then to the negative n power. So is that equal to 1? Well, technically, I know it's weird, but if n was 0, then 0 to the 0 power is 1. I know it's weird. Don't ask. There's a video on that somewhere. You could probably look it up. But yes, but what if n was 2 or n is 1, right? Ooh, what if n was 1? Ooh, let's think about this one. If n is 1, so that's going to be 0 to the negative 1 power, right? So if that's 0 to the negative 1 power, that means, remember that negative 1 means that that 0 goes to the bottom, right? So that's going to be 1 over 0. Ooh. Have you ever tried to break your calculator? Yeah, try 1 divided by 0. See what happens. Do you see what happens? You try it out. Yeah, break your calculator. And I'm not even there. Yeah, so that doesn't work. So that's definitely not 1, right? If it was like a positive, if it was 0 to the negative of a negative 1, which would make that positive 1, that would just be 0 at that point, right? And then we'd have 0. So yeah, this is it 1? Yeah, sometimes. Some people may say never, but yeah, just for the fact that if it's 0 to the 0 power, it does technically equal 1. Okay, just saying. All right, but that's the only instance. Because all the other ones, it would either equal undefined, like you can't divide by 0. For me personally, I think it's infinite, like infinity, that's the answer. But you know, because how many times is 0 going to be 1? As many times as 1, it's infinite number of times, right? If you have 1 cookie and no people, how many cookies can that no person get? Okay, that doesn't make any sense, but do you see what I'm saying? Yeah, it's a weird one. You don't want to divide by 0. But then if it is, yeah, but then anyways, we're gonna move on. So if n is an integer, then x to the negative n, so n is an integer. It doesn't say if it has to be positive or negative, right? Didn't say that. But then n x to the negative n is greater than 1. But 0 is an integer. And then 0, because anything to the 0 power is 1. And 1 is not greater than 1, right? So okay, there's that example, right? So if n is 0, then x to the 0 is equal to 1, right? But if n is, let's say, 2, right? It's n to the 2. Now this is a lot of thinking going on, right? But it's really good for your brain, I promise. Even though it hurts your brain a little bit, it's good to like try different numbers. So, like see how I tried 2 for this n. So maybe you try like 5, see if it works, like try out, do some experiments with numbers, right? That's how you get to know them better, right? So you guys become good friends. And so here's n, and so let's try this out. So this is going to be x to the negative 2, right? Well, I guess it depends on what this x is, because if x is, we know that this would be 1 over x squared. I mean, if x is, this doesn't say anything about x. If x is a negative number, well, then it'll still be positive. That's true. But, okay, I'm trying to find counterexamples here, right? What if n was 3? Okay, so if n is 3, that means it would be x to the negative 3, which is 1 over x to the 3. And now if x is negative here, then it would still be negative. Do you see what I did there? I noticed that if it was squared, it would always be positive. So I'm trying to like find examples of making it this like not true, right? So I think a lot of teenagers are good at that, because what do you guys do when like somebody tells you you can't do that? Or like your parents are like, oh, you can't do that. I can. There's an, and you find some example, right? Actually, yeah, that's what I did. I don't know if you do that. Maybe you're a better kid than I was. But you're like, no, well, that's not always true. See that right there, that's like math thinking, right? That's like you're finding counterexamples. That was what I was trying to do. I was trying to find counterexamples. So is it always greater than 1? As you can see here, not always. It can be, but not always. So here we're gonna say sometimes. All right, so which is not, okay, and if you did not do 14 and 15, these are our last problems. We're almost there. So if you did not do it yet, please pause and then do it. Should I just be like frozen? It's like paused. And you're like, did I pause it or did I not? Okay, so here we go. So which is not equivalent to the other 3? Okay, which one does not belong? I feel like there's a, which one of these do not belong to the others or whatever. There's a song about that. But anyways, 1 over 25. Okay, there's not much to simplify there. So we're just gonna leave it at that. And then 5 to the negative 2 power, we know that is equal to 1 over 5 squared. But we know that 5 squared is just 25, so it's 1 over 25. Ooh, okay, I'm thinking that's going to be 1 over 25, right? So, ooh, what is this? 400ths? I'm going to just write that as a, okay, so this name is not 0.04, right? It's 400ths. And I like to think of it as 2 decimal places, which means that there are 2 zeros on the denominator. So it's 100, right? So it's 100. So it's 4 out of 100. 400ths. That's how you would say that, right? And so I can simplify this, right? Because I know 4 goes in 125 times. So it's 1 over 25. What? All 3 of these. And then we have negative 25. Yeah, this is the one that does not, that's not equal, right? By a long shot. Great. So now we're going to select all the ones that are equivalent to 1 over 6 squared. And I like to just write this down a little bit simpler, 1 over 36. So, okay, we're like 36. Yeah, that's not it. We're like, oh yes, this one, 1 over 36 is exactly what we're looking for. Okay, let's see here. So 1, remember this is just 1 over 6 times 1 over 6. It says 1 over 6 squared, so that multiplied twice, which is 1 over 36. Or you can be like 1 squared, which is 1, 6 squared, which is 36. Either way is fine. And which is also equivalent. And this, oh look, we just did this above. And we know that this is equal to 1 over 36. So happy days. And 3.6, yeah, that's not the same thing as 1/36. So that is a no-go. And congratulations, we have made it to the end. Join me. You'll see me in another one, a couple of the videos, okay? I'll see you later. If I can see the stop, okay? All right, bye.